This manuscript explores life, death, what lies beyond, all through the lens of classical physics. This process of exploration is a journey in itself, and we have made significant progress in developing this line of thought throughout our previous sessions. In this session, we'll delve into the science of absorption. Let's ponder over these questions. How does an object acquire energy? How does the ice melt? How does the diamond shine? And then let's evaluate how the science of absorption affects the ELF beam forms. What that absorption of ELF beam leads to. All right, let's baseline our understanding with this statement. Any physical object can acquire energy if the energy inflow offers matching quanta of energy that fills the energy gap of the object to let it transition from its current energy state to the next. Different objects absorb electromagnetic radiations more effectively at specific frequencies or wavelengths. Let's take example of ice. If we keep this bowl of ice in an electromagnetic wave insulated enclosure that also insulates the heat and keep the temperature of the enclosure at 0 degrees Celsius. And if we keep bombarding the bowl of ice cubes with visible light rays, the ice cubes won't melt. But in the same condition, instead of visible light rays, if we keep bombarding the bowl of ice cubes with infrared rays, the ice cubes would melt shortly. The reason is ice primarily absorbs infrared radiation because the energy in infrared light corresponds to the vibrational energy levels of water molecules. When infrared beams hit the ice, they efficiently excite the vibration modes of the water molecules, causing the ice to absorb energy and heat up. And this leads to melting. Visible light has higher energy than infrared light. But ice is relatively transparent to most wavelengths in this visible spectrum. This means that when visible light strikes the ice, most of it passes through without being absorbed. As a result, very little energy is transferred to the ice, so it doesn't heat up significantly. The small amount of energy that might be absorbed from visible light is insufficient to cause melting under the same condition where infrared would. For the ice cubes to melt, it needs to absorb sufficient energy to raise its temperature to the melting point and provide the latent heat of fusion. Infrared light is far more efficient at delivering this energy because it is absorbed by the ice and converted into heat. In contrast, visible light would not provide enough energy in this scenario, especially in a heat insulated room because it doesn't interact strongly with the ice molecules. Let's take another example. Let's consider electromagnetic wave insulated enclosure that is completely dark from inside. And let us keep a well-cut diamond in it. Now, bombarding a diamond with infrared beams inside this enclosure would not make the diamond shine. The diamond would not scatter and refract infrared rays, but the diamond would shine if in the same enclosure, if we are bombarding it with visible light rays or UV rays, ultraviolet rays. The diamond would scatter and refract the visible light and UV rays to create the sparkling effect. Reason being, the band gap of diamond is around 5.5 electron volt, which corresponds to ultraviolet light. This means that only higher energy photons like those in ultraviolet and visible light spectrum can excite the electrons across this band gap. Infrared light has much lower energy level in the order of 0.001 to 1.65 electron volt, and that is insufficient to excite the electrons in diamond. Continuing the line of thinking, what will happen when an embryo with developed heart and cardiovascular system would seek the energy to pick up the rhythm of life? Imagine this situation. The embryo has got the cardiovascular system developed. The ultrasound captures few irregular beats. Now, the embryo requires an oscillating electric field that will make the heartbeats faster and with the rhythm, and the ions will start flowing through the circulatory system to bring the necessary current. And along with that, there should be an oscillating magnetic field to complement the electric field as per the laws of physics. But how would the embryo acquire this electromagnetic energy of specific frequency and magnitude so that it comes to life? Contrary to the popular notion, this jump of energy to cover the specific energy gap cannot happen by gaining the energy bit by bit through the dietary sources of calories and nutrients. Every case of acquiring energy to cover specific energy gap of an object always require the process of absorption. And during that process, the exact quanta of energy is absorbed from the adjacent energy source, where the particular quanta of energy of specific frequency and magnitude is available. So dietary process of fetus won't be able to supplement this energy gap of specific quanta. It would require absorbing an ELF beam of matching profile. And that's precisely what happens during this process. One of the ELF beams available in adjacency and matching the frequency, magnitude, and beam profile of the energy gap gets absorbed by this ready to come to life embryo, and then it comes to life through that absorption process. Sometimes the burden of our current knowledge makes it difficult to accept something different. Fresh perspectives can spark doubts. Is it accurate? Is it true? And most often in those situations, we look for others' acceptance. Is it well accepted by others? It's understandable if some of our previous sessions have stirred up some of these questions for you. This session is another step in that journey, challenging established ideas and presenting a fresh viewpoint. At times, it's essential to set aside traditional understanding and consider things new from a different lens. We believe that once you have reflected on this, clarity will follow, and you may come to see the need to rethink the traditional views on knowledge, perhaps sooner than later. All right, that's how far we would go today. The line of thinking we have been developing so far has started to take the shape now. But there is more. Keep watching.